Continuing in 3.3, division of polynomials, remainder and factor theorems. So let's look at an example of this. What we previously did was remainder theorem, factor theorem, and synthetic division. We will be doing both division, long division, and synthetic, but we use this quite a few times to see if the polynomial factors. So we're going to use the factor theorem and this concept right now. So and the fact that and the remainder theorem. So this is we basically put these two together. So this is the idea. Let's take a look at this. So given f of x is x to the fourth plus x cubed minus 6x squared minus 5x minus 15, show that negative 3 is a zero or root of f using the synthetic division. So the idea is that a zero or root means, by definition, that f of negative 3, when you plug it in, that's your x value, right, has to equal 0. Okay, that's what we want to show. So show this. Now, one way of doing that is to just plug it in, is to just substitute in, raise it to the fourth power, to the third, etc., and simplify it, and then you should get 0. But this technique is actually quicker than evaluating it at the negative 3. Plus, it gives us some more information as well, because it actually helps factor the polynomial if it is indeed a 0. So, so the remainder theorem will say it'll be f of x plus d of x, which is the divisor, times your quotient q of x. And then if it is indeed a 0, you'll have plus 0 for your remainder. In other words, r of x is equal to 0, which is exactly what we want to show. So factor theorem says if f of x is equal to 0, or f of negative 3 is equal to 0, then x minus the negative 3 is a factor. Meaning that you get this factored form, right? You get this form like that with no plus there. That's a 0. Okay, so let's do it. So synthetic division, this is your c. So c is your negative 3, like that. And you put negative 3, and then you divide into it like this, writing down the coefficients, 4, 3, 2, 1, constant, so no terms are missing. So 1, 1, negative 6, negative 5, and negative 15, like that. And then you do one space, one character space, like something like that. So you can put values in there. You bring down the 1, and then multiply, add, multiply, add, multiply, add, and yes, that's what we should get, because we get 15, which is the opposite of negative 15, and there you go. There's your 0. That's what we wanted. So we wanted that to be r of x, which is our 0 remainder. So what this means then is you have this factored form. So you have, I mean, that was really all they asked you to do, but you have this polynomial, and then this equals x plus 3 times, and then how is this? What does that look like? Well, you always want to know that this reduces by 1 degree. So when you do that, you get x cubed minus 2x squared. And you can say a plus 0x if you want, or just say minus 5. So that's how it factors. So then from there, what you could do is if you had another reason to know that there's another factor, then you just use this polynomial to see if you end up with another factor. And the goal for this is to get all the zeros of f and be able to graph the function, which we'll get into a little later. Okay, so so there's my example, or an example of using synthetic division for our application, what we're doing. Next, we're going to do a little review of complex numbers. So review of complex numbers. So complex numbers are like the bigger set than the real numbers. So in other words, all of the real numbers are in the set of complex numbers. And it looks like this. So the form we use for a complex number is a plus bi, like that. Where a and b are real numbers, so where a and b are real numbers, and I is defined to be the square root of -1, where I squared is equal to -1. So you square something and get a negative value. The root of this, the fundamental concept, started with trying to solve x squared plus 1 equal to 0. So what's the solution to that? Well, you're going to square something, add 1, and you need it to be 0. So you need this to be negative. So someone said, let's just make it up. It's just only something I can imagine. So what you put in here is plus or minus I. And then the plus or minus becomes positive, but I squared is negative. So you get -1 plus 1 is equal to 0. So that's where it came from. And then it's a whole field of study that has many, many applications. Okay, so let's look at this. So this looks like a coordinate system, maybe just the xy coordinate system, but it's actually not. So this is called the real axis, which is r, and this is the imaginary axis. So we call I is called an imaginary number. But I is 0, or it zeroes out on the real axis like this. Everywhere else, you would have an ordered pair. Now, we're not going to do much with this. This is called the complex plane. So this is the complex plane. We're not going to do much with it, but I just want to introduce you to that idea. So if you do 5, so for example, if you count 5, so 1, 2, 3, 4, 5, you don't have to be perfect there, and then up 3. So this is 5 plus 3i. And then you could have another value like -5 down maybe -2. So -5 minus 2i would be down here like that. So if imaginary, so just abbreviate that. So this is the imaginary axis here. Oh, so we call this usually A, and this is the BI part right there. So when you add and subtract imaginary numbers, just look at that, you really just add and subtract just like it's a variable, really. So we'll do add, subtract concept. So suppose I have the first one A, let's call this an example. Adding, subtracting, I'm just going to give you this as an example. 5 plus 3i plus -5 minus 2i. And what you do is you add the real parts together, and then you add the imaginary parts together. So A is the real part, and B is the imaginary part, but both A and B are real numbers. So it's a little strange, but that's how it works out. So when you add this up, you get equal to 5 minus 5 plus 3i minus 2i. So it's 0 plus I, or just I. So this is what we call pure imaginary, because there's no real part to it. It's just the imaginary part. Okay, let's see. Well, try this one. So B, so if you had 2 minus 4i minus this subtraction, 5 plus I plus 6i, and you just try it. You just add the real parts together and the imaginary parts together. So it's 2 minus 5 minus 4i minus 6i. So negative 3 minus 10i. So that would be. Okay, next example is multiplication. So this you multiply just like you would two binomials. So you just take the first term and distribute to 3, and then you do it again to the 2, and you multiply the constants. And then we multiply the negative 4 times the 3, and then negative 4 times the 2. But then you'll have I squared. This is the only place, this last one here, you'll end up with I squared, and then you have to do something with that. Well, what is I squared? I squared is negative 1. So do that product. Try that on your own. Okay, now let's continue. So you get 6 plus 4i minus 12i minus 8i squared. So that's the place where you have to do something. So here, with that negative I, or I squared, you have to make that a negative 1. So it just becomes a plus 1. So you get, this is equal to 6. And we can add those up. Negative 8i, and then it's minus 8, and that's a negative 1. So it's 6 minus 8i plus 8. 6 plus 8 would be 14. So you get 14 minus 8i. So that's multiplication. Next is what we call conjugates. So conjugates of numbers is basically exchanging the sign in between. This is a simplified version of this, but so we have a plus b and a minus b. Those are called conjugates. So complex conjugates look like this. Complex conjugates is a plus bi times a minus bi. So those are conjugates for complex. You just change the sign in the middle. Literally, that's what you write down, like change the sign in the middle. So let's do an example of that. If you have conjugates, so 2 minus 3i, then the conjugate of that would be 2 plus 3i. So here's the deal. When you multiply complex conjugates, you always get a real number. This is going to be real. The I part disappears. So do that product, see what you get. And then I'm going to remind you, though, when you have a plus bi times a minus bi, anybody recognize that form? What's that form? That's the form of difference of squares. That's a squared minus b squared. Okay, and you can verify that by multiplying it out. I'll leave that to you to do that. So this becomes 4 minus 3i squared, or let's just make that a 2 squared. So it's 2 squared minus 3i squared. So that's 4 minus 9i squared, or 4 plus 9. So that's just going to be 13. 9, 10, 11, 12, 13. Okay, so quick overview of complex numbers. This will be used when we get into 3.4 or on zeros and roots of polynomials, because there's some theorems we're going to be looking at in that section. And the concept of zeros and roots of polynomials. So we'll do that in the next video.